How can you prevent op-amp oscillations from feedback? Imagine turning on a radio and hearing a loud screech instead of music. That noise is similar to what happens when an operational amplifier starts to oscillate. It can cause your circuit to malfunction or produce unwanted signals. So, how do you keep your op-amp stable and prevent these oscillations from happening? Let's explore some straightforward methods. First, it's important to understand that oscillations often happen because of phase delay in the feedback loop. When the feedback signal gets delayed too much, it can turn negative feedback into positive feedback, which leads to oscillations. To stop this, you want to minimize that delay. One way is to keep the feedback loop short by reducing the length of circuit board traces and avoiding stray capacitance. This helps the feedback signal stay in sync with the output. Next, look at the resistances in your feedback network. If you lower these resistances, it can push the pole created by any parasitic capacitance to a higher frequency. That means the circuit remains stable at the frequencies you care about. But be careful, reducing resistance can increase the load on your op-amp, so find a good balance. Adding a capacitor in parallel with a resistor in the feedback loop is another effective trick. This is called capacitive compensation. It helps cut down the gain at high frequencies, making the circuit less likely to oscillate. This method is especially useful when your op-amp isn't stable at unity gain, which means it can't operate with a gain of 1 without oscillating. You can also increase the overall closed-loop gain of your circuit. Higher gain levels tend to reduce the loop gain at problematic frequencies, which helps prevent oscillations. Think of it as making the feedback signal less influential at those frequencies. Driving a capacitive load can cause extra poles in the feedback loop, leading to instability. To fix this, you can add a small series resistor between the op-amp output and the load. This resistor isolates the op-amp from the capacitive load and keeps the circuit stable. Using an op-amp with low output resistance also helps. Finally, choosing the right op-amp is key. Some op-amps are designed to be stable at unity gain, meaning they won't oscillate even when configured with a gain of 1. Picking an op-amp that matches your circuit's needs can save you a lot of trouble. By combining these strategies, shortening feedback paths, adjusting resistances, adding compensation capacitors, increasing gain, managing loads, and selecting the right op-amp, you can keep your circuit stable and free from unwanted oscillations. This way, your electronics will work reliably and smoothly every time.